Before we solve any problems regarding inequalities, I just want to go over a couple basic ideas. First idea is the primary difference between inequalities and equations can be found in the solutions to each type of problem. With equations, one will arrive at a finite number of solutions. In other words, equations generally lead to a number of solutions that can be listed out. If you recall from our previous problems, our previous homeworks, when you solve an equation, we always get something like x equals 5, x equals 2, 3, or 5. Remember from the exam review where we were solving some of those problems that had the replacement set, we've seen which numbers worked. So what we're saying here is when you solve an equation, you get a countable number of solutions. That's considered finite. With an inequality, the difference is the solutions are infinite, and thus we must report using something called set building notation to signify that there exists a multitude of correct answers. In other words, when we solve an equation, we get one answer. We get 3 answers, so on and so forth. You could list the actual numbers, the finite numbers out. With an inequality, you might get something like x is greater than 5, which means that anything bigger than 5 would work. 5.1, 5.2, 11, 205, 2005, 2,000,005. And so because there's so many answers, we go to something called set building notation. Set building notation we'll go over here in just a few minutes. I want to talk about some other ideas before I get into all of the set building notation. The concept when it comes to solving inequalities is that everything will be identical to solve an equation. It's just a review of the previous ideas that we've been taught. There is one particular rule that you do have to pay attention to. By the way, these notes here are listed on the website, so you can print them out at a later time. The examples are not, so you will need to take notes on the videos. So here's our rule. The rule says anytime the inequality is either multiplied or divided by a negative value on both sides, then the inequality must change direction. In other words, when you multiply by a negative on both sides of the inequality, when you divide by a negative on both sides of the inequality, you must switch the direction of the inequality. This is going to be a major rule for this chapter. If you don't follow that, you're going to have all kinds of problems. It has to be followed. Major rule. And then I'll go ahead and jump into some of these examples of set building notation. The set building notation looks just like this. It's the set notation where you do the S, the backwards S. And then how it's read is this. The set x such that x is less than or equal to 5. Now when you solve your problems, you're going to write set building notation and then you're going to graph it. And the graphing shouldn't be anything that takes a whole lot of time. You simply locate the 0, that's the most important number on a number line, and then your critical value here is 5. So on my number line, I locate 5, and then I simply have to decide whether I can have 5 or whether I must exclude that value. In this case it says x is less than or equal to 5, which means I can have 5, so I'll make that a colored in circle. That means I can have that value. And then because of the way that we write the set building notation, it's always the variable such that the variable always has to be on the left hand side. And the reason why we do this is it tells you what direction to shade in. In this case it's saying shade to the left, so I shade to the left. And when you shade just like I am. Make it crazy so we can see it. That's shading for me. This is easy to read. It tells me that you wanted every value including 5 and everything less than 5. There's a multitude of answers, an infinite number of values that are being represented there. We'll go to the next one. It says the set y such that y is greater than 3 1/4. So because it's already written here, all I'm going to do is graph. For this problem, I locate 0. 3 1/4 would be found to the right. You don't have to count it out, just as long as you know it's to the right. And it says greater than 3 1/4. So it means I can't have it. Since I can't have that value, I will make an open circle there, meaning that that value is excluded, and then I just follow the arrow. It points to the right. It tells me shade to the right. And so that's what I shade. Just like that. For the third example, it says the set W such that W is less than negative 13 and 1/2. So here's my 0. I'll know that negative 13 and 1/2 is going to be to the left. So I go negative 13 and 1/2. Now it says strictly less than. So should I color in the circle? No, because it doesn't have the equal. I have to exclude that value. And then basically the set building notation is idiot proof. It tells you what direction to shade. So I shade off to the left. And our last example here, example number 4 for shading. I locate my 0. It says the set T such that T is greater than or equal to negative 13 and 1/2. So again, with it being negative 13 and 1/2, I'll go over to the left. And the question is, do I want to have a closed circle or an open circle? Do I want it shaded or do I want it open? With the equality, it means that I want to include the value. So I do shade it in. And again, it tells me what direction to shade. It says shade off to the right. So this is what all your answers are going to look like as you go through the homework problems. This is called set building notation. It necessitates that the variable is always listed to the left side of the statement so that you know what direction to shade in. And we'll go do that as we do a few of our example problems. I'll explain that a little bit better. When equality is present, the circle can be shaded in. With strict inequality, the circle can be left open. And that's what I'm talking about here. When you have the equals, it's shaded in. When you have the equals, it's shaded in. When it's a strict inequality, it just says strictly greater than, then it's an open circle. Strictly less than is an open circle. Greater than or equal to means it's shaded in. Equality, the extra little mark, means you include the circle, you color it in. Strict inequalities are left open.